All right, so the last section in this chapter is linear regression. And the biggest thing that we're going to really take from this is how to do it in Excel and on a graphing calculator, but I prefer you really learn it in Excel. And the reason why is you're all in a business program. You're going to have to know Excel, and this will help you predict the future. So this is an extension of the last section. And in the note packet, it's talking about different solving real world problems, kind of like you construct a model, you solve the model, and you interpret the solution. That's what it's walking through here. And then it shows you how to do it on the graphing calculator. I'm also going to show it on Excel. So the first question isn't going to do, it's like, here's the first one. So we'll do problems 1 and 2, but problem 3 is more like where we're going to use that technology. So look at this. We have stress test is X, and we have blood pressure is Y. And those are each representing a person, right, as those points. So the first point is 5570, and that represents one person. And then this is another person, this is another person, and so forth. So we can take data and we can use it to predict things. And it's super cool, and it can be very helpful. So we can find this equation. It's called linear regression, line of best fit. I can't think of any other name for it. And you can find that on technology. So the first piece of technology that I want to show it on is the graphing, or maybe I'll do Excel first. So let me stop sharing on this real quick. And I am going to share here, and I'm going to open an Excel. So just so you know, you have the web version of Excel through Office 360. It's not as good. So you can download the Office suite from your email. Every year I try to show that on here, but then you see my email and it's too personal, and I have students' names in there, so I can't really show that real well. But in your email, when you log in, you can go to the Office suite, the little dots in the corner, and you can download Excel. So let's put in the data that we were given. So our we're going to do ours downward, so our X's are going to go down, and that one went 55, 62, 58, 78, 92, 88, 75, and 80. Again, this is problem 3. And then 55 went with 70, 85, 72, 85, 96, 90, 82, and 85. Okay, so these are our points, and we can highlight our X's and Y's, and we're going to go to insert. Okay, insert, and we want to insert a chart. Notice the scatter plot where it has the dots. That's what we want, and we don't want them linked, so it's just that first one. This is your scatter plot of this data. Does it look like it forms a line? Yeah, it does. It's a pretty good line. So it has a linear relationship. So our X's were our stress test and our blood pressure. So as they stress you out more, your blood pressure does go up. They're related. So more stress, the higher your blood pressure. So you're going to go to this plus over here, and you're going to go down here and say, click, I would like to add a trend line. Well, that isn't even very helpful. So it puts some random dotty line on there. Then you have to go over here and click this and go to more options. This is where you really want to be. I got to move my face, and I want it to be linear. There are other types. If your graph was, curving some way, you would pick a different kind. Go all the way down here, and I want you to display the equation on your chart. Ta-da! There you go. And that does match, unless I got a data off. It match. Oh, I did get a data number off. This was supposed to be 62. You might have caught that. Does that change? Yep, and it changed my equation for me. Oh, that's even, they used to not do that. That's amazing. Watch, if I change this 58 to 50, everything changes. How cool. I didn't even notice that before. Sorry, the things I found fun. Okay, so I was just making sure it matched the equation they wrote on that problem 3. So again, what did I do? I put the data in, I highlighted it, I went to insert, over here to a scatter plot, click it down here, and then you had to go to that side thing. I'll show it again. I thought it would come up. Yeah. So click, don't be afraid to just click around. So I clicked the plus, add the trend line, but I have to go to the arrow. I have to go to more so that I can, on the bottom, display it. And you can display the R value too. If you're in statistics, you'll learn about R and R squared, correlation coefficient, and correlation. Oh goodness, I forgot what the R correlation coefficient is. R squared is the variance of the correlation. Something with variance, I can't remember the exact wording. But basically, if you took, this is R squared, so if you took the square root of that, how close is it to 1 is how good your relationship is. So on this one, it's pretty similar to a straight line here. Yeah. So the R, so if I take the square root of that number, 0.8118, is 0.90 something. So it's about a 90% relationship between X and Y. Okay, so that's kind of cool. All right, so same idea, but now I'm going to show it on the graphing calculator for you. Okay, so gotta share advanced, and I got a second camera. Oh, I gotta plug it in real quick. Just kidding. All right, second camera, share. Okay, so here's my graphing calculator. Should come in pretty clear. And the first thing you're going to do for this, I got to turn back on my, I need my data. iPad died. Okay, so we're going to go, the first place we're going to go is stats. So here's our stat button right here. And in the edit, that very first one is where we have lists. So stat enter is going to get you to those lists. So I have information in there. So I'm going to highlight the list one and push clear and then enter, and that will wipe out your data. So I'm going to go up, highlight the top, clear, enter. If you push delete, it will actually delete the list and really mess things up. So give me a call if you accidentally do that, or Google it, how to bring my lists back with undelete, which would be insert. So L1, we're here. These are our X values. So we have 55, 62, 58, 78, 92, 88, 75, and 80. Okay, and then go over to list 2 and put in my Y's, which will be 70, 85, 72, 85, 96, 90, 82, 85. Okay, and they should match each other so you can double check your numbers and everything. So I'm going to then hit stat again. So I put the data in, and then I'm going to go over to calculate. Okay, so right now I'm in edit. I'm going to go over to calculate, and I want a linear regression. Linear regression, enter, and then it's already got list 1 and list 2, so you could just do enter and then calculate. And it doesn't do mx plus b, it does ax plus b. So there's your slope, there's your y-intercept. They match the problem, they matched what we got. So again, stat enter is the data. Stat arrow over down to linear regression, and enter, 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 enter. Ta-da. Okay, those are your 2 ways to get a line of best fit, or a regression line, or, you know, whatever else we want to call it, right? Okay, so let's go through some of these homework problems that are not exactly what we just did, but that is part of your homework, and it will tell you, like, use technology. This class has an Excel part to it, so you will actually have to know the Excel piece for some things at the end of the class. Okay, so I'd like you to learn Excel. That's where I'm at. All right, let's go back. So let's start on problem 1, and we'll do a couple questions. So problem 1 is depreciation, and it is saying Final depreciation. A new car is worth 45,000. It's depreciating about 5,000 per year. Right now, they aren't really depreciating because, quite frankly, used cars are worth a ton, and this is 2023. You might watch this video next semester. Maybe it'll stop being crazy. But so A says find the linear model for the current value of the car. Okay, so for A, we know it's worth 45,000, but we're going down 5,000 per year. So the current value of the car, we'll do V, and they say, why? Why would they use Y where the X always is? That's weird. Okay. They say years, use Y. Oh, I guess year starts with a Y. Okay. Sometimes I'm smart, sometimes I'm not. What is the slope if we are depreciating 5,000? Negative 5,000. Why? Because we're going down, we're depreciating, not appreciating. And then we would add the 45,000. If you put this in a different order, you would still be correct. So you could do 45,000 minus 5,000 Y or X or whatever value you wanted. Okay, interpret the slope. So part B says interpret the slope. The slope is negative 5,000. You would interpret it as you go down $5,000 per year. You need that word per in it. That's how you interpret a slope. It's so much per whatever the denominator is. C, if the car is 3 years old, how much, so let's predict the value. If the car is 3 years old, what does the model predict for its value? So the value is going to equal, so years is Y. So we'll do 3 there plus the 45,000. You could probably already do this in your head because you're just going down $5,000 per year. So you could see that's 30,000. So the value of that car after 3 years is around 30,000. D, after how many years will the car be worth nothing? Okay, well, the value would be 0, right? For the negative 500,000, Y plus the 45,000. I like how I just randomly write the Y's different. I do that with 2's too. Okay, so I would need to minus the 45,000 over, and then I would divide by the negative 5,000. I end up with 9. 9 years. In 9 years, basically, you've lost value of that car. Down to nothing. I don't know that any car is ever worth nothing, right? You can get a salvage guy to come take it for something. Okay. Right now, you could probably still get 20 grand for a used car that started at 45. Okay. That one's really almost the same. Let's look at what else they ask on 3. So they had already given the equation on 3, and then I made you find it. So 1A says, interpret the slope of this model. So the 0.56-ish, right, is our slope. And it's when we do our slope, so for A on this one, it's a little harder for this one. But your slope, right, is going to be the Y's, which is blood pressure. I forgot another O in there, pressure, over, I got to rewrite that. That is some awesome writing. Blood pressure over the stress test score. So if we have 0.56 is our slope over 1, basically you're saying you're going to go up 0.56 blood pressure. I don't remember what it's measured in, like beats per minute, whatever it is. Blood pressure things. You go up 0.56 per 1 on the stress test. I don't like that interpretation all that well, but and then what does B say? C say, we're on C. No, B. Use the model to predict the blood pressure for a stress test score of 75. So you would put the stress test score is the X, right? So you would put that value into X for B. So it becomes Y equals 0.56 times the 75 plus the 41.71. throw that into your calculator. And I do not know what 0.56, it's about half times 75 plus 41.71. It's about 83. Okay, about 83. All right, and then this one, C says, use the model to estimate. So it's just putting the value now into the Y instead. So it's going to be 90 equals 0.56x plus 41.71. So you'd have to minus the 41.71 over. So I'm going to do that in my calculator. 90 minus 41.71 is 48.29 equals the 0.56x. Now divide by 0.56. And I get 86.23-ish. Okay. So the one thing that these note packets don't do well, which is what I've already showed you, is taking this this data and making the equation. It does well showing the equation, but it doesn't do well making it. So like problem 1, you're going to have to write the equation given some kind of information sometimes, and sometimes you'll write the equation of the line of best fit using technology. All right, let me know if you need help.